Welcome to the fourth video in the sixth chapter of the Crystal Clear Electronics series. We have already heard about the stabilization of the output voltage in the previous video, but I'm interested in what you have to say about the input of the power supply. Are there any crucial things to look out for?
Yes, of course there are some. Unfortunately, there are many ways to damage a power supply, for example by connecting the wrong polarity or connecting more than the maximum allowed voltage to the inputs of the power supply. Fortunately, most of these can be prevented by inserting various circuit elements. Let's discuss the polarity protection at first. With this, it's avoidable that an inversely connected plug makes our circuit fail. The plug is what goes into the input of the power supply. For this purpose, we need a component which allows our circuit to operate in one direction only. As we can see on the figure, for a problem like this, a perfect solution is one of the simplest semiconductor components, the diode. For the time being, it is enough to look at it that allows the current to flow in one direction only. A diode has two terminals, the anode and the cathode. The current is able to flow only from the anode to the cathode. With the help of a diode, we can protect our power supply against reverse polarity wiring. Connecting the diode between the positive output of the source and the input of the 7805 component, it allows through only positive direction current, which can happen only if the connected voltage is positive. Please, Danny, let's install the diode protection on the input of our power circuit. What do we need to pay attention to?
I assume we have to check whether our diode is wired correctly and in the right direction.
So you mean the polarity?
Right.
This is due to the fact that the current can only ever flow from the anode to the cathode if you use your diode properly. How do you know which leg is which?
On the diode there is always a mark that shows which leg is the anode and the cathode. On the cathode side we can find a stripe marking.
I see. So if everything is done correctly, the same output voltage will appear on the power supply output as before. Now you have inserted the diode instead of the jumper wire. And the LEDs on the output still light up nicely. Let's measure the current flowing through the diode. What do we find?
Okay. To do this, I first modify the input of the multimeter and switch it again to the current measurement. Then I open the circuit and measure the current flowing through the input. As expected, 48.1 milliamps is currently flowing through the circuit, which is close to the 50 milliamps value.
Great! And one more thing to note is that you open the circuit to measure the current, but it's actually the multimeter that closes it, so everything flows through it. Awesome! Now let's see the real trial. Deliberately connect your source to the input in the other way. In this case, the diode should block the current, and so we hope that our circuit will not, or rather we are sure that it will not fail. But, first of all, remove this voltage divider power supply part, because it does not have reverse polarity protection on its input. So we remove it so that it doesn't fail. And, after that, we could also show that if we close the circuit, it still lights up. It was opened when we measured the current, so we have a working circuit. And now we take this one out.
First, let's reverse the polarity of the power source.
Okay, nice.
You can see that the LEDs don't light up. After we measure the current, we can see that there is no current running through the power supply.
This is really great. And just to make sure that everything is okay, maybe we can put it back the way it was and see that we still have the circuit working and nothing has blown up. We've protected all the components. We can put back the jumper instead of the multimeter. Everything is perfect. Great. So in the end, what we found was that with the diode, with this very simple component, we could make sure that our circuit would not fail even if we connected it the wrong way. The only problem was that it didn't work if you connected it the wrong way. It would be nice to solve it so that if I connect the input of the power supply with reverse polarity, it still works somehow. Is this possible?
I think so, yes.
Yes. And the solution is a so-called Grates circuit, also known as Grates bridge rectifier, which is made up of 4 diodes. Build the circuit and try how it works. Watch out to connect the diodes appropriately. The circuit above is usually called Grates bridge, Grates circuit, or Grates rectifier as well.
So now on the breadboard, I connect the rectifier diodes in the correct way. It may seem a bit complicated at first, but it's really a simple circuit. And in principle, if I now put the power supply on in the opposite direction, so I connected it with reverse polarity, we should see the LEDs light up in the same way.
Let's try it.
And it works.
Beautiful. Let's see what has happened in our figure. We can make our power supply polarity independent by using 4 diodes. This means that our power supply will work if we connect the voltage to its input in a positive way, and it will also work if we connect the voltage to its input negatively. In case of positive connection, the current will flow through the D1 and D4 diodes, as you can see. In the case of negative connection, the D2 and the D3 diodes will conduct. Now everything is okay, and you can understand how our small circuit is working.
And what can we do if we mistakenly connect our power supply to a voltage that's too high? Is there any method to protect the circuit from it?
Of course, there's a solution to this, and not just reverse polarity. For our power supply's overvoltage protection, we need a component which is able to absorb a dangerously high voltage. On our wiring diagram, it is marked with a small lightning symbol. For this problem, quite a good solution is a Zener diode. This component is also a kind of diode. It can be greatly used for overvoltage protection thanks to its special property. You can hear more about this later in the curriculum too. For now, it's enough to know that if there is a higher voltage on it than the threshold voltage, it can conduct inversely too, i.e. from the cathode to the anode. Let's look at the following 3 cases in the diagram. If the voltage is not too high, only 12 volts, the Zener diode acts as a normal diode that conducts from the anode to the cathode but not in reverse. If the reverse voltage is increased to 33 volts, the diode will also start to conduct from the cathode to the anode.
So, if the Zener diode can conduct current in the reverse direction above a certain voltage, can we use it for voltage protection?
Yes, this is exactly what I wanted to express with the previous figure. So, with the Zener diode, we will protect our power supply from too high input voltage. There are several different threshold voltages of these diodes. For us, for example, the 33-volt Zener diode is the most suitable for building the protection, since our power supply needs to be protected from voltages higher than 35 volts according to the datasheet. There are several Zener diodes on the market, and we have to look at this breakdown voltage as the most important parameter when it has to be driven in the reverse direction. So, before we build this overvoltage protection, one more important thing is to add the fuse so that neither the Zener diode nor the voltage source connected to the input can be destroyed when the Zener diode starts to conduct in the reversed state. We also have a figure here. Let's examine this issue theoretically. If the voltage of the input is higher than 33 volts, then a current will start to flow through the Zener diode, as the figure below shows that too, by using an imaginary 40-volt voltage source. So you can imagine that below 33 volts, the resistance of the Zener diode at the present polarity is almost infinite. From the point of view of the circuit, it is as if it was not even there. Above 33 volts, it suddenly becomes a resistance of almost 0 ohms, and almost all the current flows through it, since the current always takes the easier path. From this, the fuse would burn by this current, so the too large input voltage would come off from our circuit. Like all parts, the Zener diode has a maximum allowed power too. If which is exceeded, it can be damaged. We have to choose the fuse in a way that its fusible fiber should burn before the Zener diode can be damaged. By using the components in the component list, you can't try this operation. You would need a fuse with lower value or a Zener diode with higher power. I think the time has come to build and try our circuit.
Okay, first I remove the power source. Then I insert the Zener diode between the ground and the power supply.
A föld és a táppont közé. És végül
and finally, I add the fuse to the power supply. And now, if all is true, our circuit, which is also protected against overvoltage, will be similarly functional, and because of the Grates bridge, it will work with reverse polarity as well. And luckily, the fuse is still intact.
Yes, and that's what we can test. We won't connect 40 volts for now, but I think it was understandable how it works.
We learned a lot. Can we summarize a little bit of what we have learned?
Yes, I also feel the need for that. We can summarize our knowledge of power supplies. We have learned that the output voltage of a power supply needs to be regulated. We learned this in an earlier video. Otherwise, the supply voltage, i.e. the voltage at the output of the power supply, would vary depending on the source voltage at the input and the device connected to its output. We made the input protected in two ways: polarity protection and overvoltage protection. So, if you combine the protections described above, you get a power supply that is independent of the polarity of the input and protected against overvoltage with an LED that gives information about the operation of the circuit.
Thank you very much. It's great to see a working circuit on the table. We'll say goodbye for now, but we encourage you, if you want to hear about diodes, their properties and how they work, join us in the next video. Goodbye.
Bye bye.